questions do you have on last night's homework? Are there any we're struggling with? Cool.
Set up for the full equation for 18. With the intervals for the two intervals.
Gotcha.
The bounds.
I know what you guys are going to ask me, so I'm going to go ahead and answer it right now. Mr. Westfall, how do I know when I'm allowed to graph it and how do I know when I'm not allowed to graph it? And the best answer I can give you is be able to do it both ways. If it's a nice, easy process, by easy, I don't mean it should be an algebraic process that should be considered easy at this point. If it's solvable by hand, they may ask you to solve it by hand. On my quiz, you're going to be able to use the calculator. All right. So there's the first graph, and then tab x squared. There's the second graph. By using the calculator, we do menu, analyze graph, intersection, boom, boom. So -2. And just to cut to the chase, it was -2, -1, 1, and 2. Okay? So from -2 to -1, it's going to be x squared top, the x to the fourth function bottom. From -1 to 1, it's going to be x to the fourth function top, x squared bottom. So 3 separate integrals. Plus from 1 to 2, x squared top, the x to the fourth function bottom. Good. There was no other way around it. It had to be 3 integrals. Question, could you have done right minus left on this? Give me 2 reasons why.
No, because the two areas on the sides don't pass the horizontal line.
Good. I like that. Yeah. Right, left. Ooh, same function. Issue. Can't do it. Option 2. You'd have to write this function solved for x in terms of y. Good luck. All right? That's a big hurdle. Do you agree? Can't do it. That should be a red flag to you. You're going to need those red flags in 7.3. Uh-oh, issue. Better try a different way. Okay? Any other homework questions? Wendy?
Like on 18,
yeah.
I set up equal to each other and was trying to find like where they intersect.
Yeah.
It like came out to be x equals plus minus 1, x equals plus minus 1. Which I don't know if I just solved it or not.
Might have been plus minus the square root of 4.
Okay. Oh, that makes sense. Yeah.
Okay. Might have missed a square root there. If you need me to look at it later, I'm happy to. Any other homework questions? How do we feel about this? Would be pretty straightforward. Top minus bottom. Integrate left to right. Right minus left. Integrate bottom up. We good with that? We need that for today. Yes? Okay. 7.3. Volume. So you have the title down. This is going to be a marathon. Okay? Buckle in. I guess you don't need to buckle in for a marathon. Indianapolis 500? Roller coaster. But not the top thrill dragster. All right. Volume. I sure hope you were taught volume as a stacking of areas. Were you? Do you know that? Yeah. What's a cylinder? What's the volume for a cylinder? Pi r squared h. What's pi r squared? Circle. You know what I picture? Man, back in my day, download some music on Napster, maybe some LimeWire. Okay, you like a girl, you make her a mix CD, mixtape early, and then mix CD if you're really cool. All right, you put it onto a. You ever see those spindles of the CD spindle? I still got one, I think. Anyway, isn't that a bunch of circles stacked up? That's what volume is. Volume is a bunch of circles stacked up. All right. What is a This is my perspective's off. Please forgive me. It's a pyramid. Yeah, get over it. What is a square pyramid? Isn't it a bunch of squares stacked up? But not the same size, right? They have to be different sizes as you go up, right? But isn't the volume of something, in general, formed? If it's we called it a prism. It was always the area of the base times the height, because the area of the base gets stacked up. Do you understand that? A bunch of stacking of something, stacking of areas, gives you volume. Now, stay with me here. Riemann sums. What happens when you stack a bunch of rectangles side by side? Thank you. Someone said it. A to B. Stack a bunch of rectangles. What do you get? Area. Stack rectangles side by side. Area. Stack areas. Volume. What is the stacking process? It's the accumulation of something, isn't it? Hang with me here. Accumulate a bunch of rectangles. Area. Integral accumulates f of x dx. Base, height, right? Base, height. Now we're going to be doing volumes. So how are we going to get a volume? Well, we're going to stack those a of x areas, and they might not always be like the same area. Like this one, you're stacking the same size circle up and down. But what if the squares change sizes as you go up? You need a function that tells you how they change sizes. Do you understand that? Okay. So here's the first method we're going to learn. It's called the disk method. Okay. Disk method. The disk method is used when the region being revolved is completely connected to the axis of revolution. Let me say it again. Is used when the region being revolved is completely connected to the axis of revolution. This is our first method, and it's not going to be hard to decide when to use this first method because there's only one method. Once we get to the third or fourth methods, you're going to be like, oh, what do I use here? How do I know? Well, this one, to use the disk method, the region being revolved is completely connected, no gaps between the region you're revolving and the axis you're going around. If you're dealing with x's, then you're going to need a pi r of x squared dx. And if you're dealing with y's, it's going to be pi times r of y squared dy. Does anyone know what I'm talking about when I say those party decorations? They're made out of like, I think, is it called crepe? Not crepe. Crepe's French. Crepe? Is it crepe paper or crepe paper? Crepe? It's weird. They're like, okay, they're bells. You probably know what I'm talking about. And when you unfold them like this, you know what I'm talking about? Like, they fold open and they create that like bell shaped thing, but when they're folded flat for like packaging or to sell, they're just like a flat looking bell thing, right? So here's what I want you to visualize. This is just how my mind works. Sorry. pretend like you're looking at that side of that bell. Okay, this is the x-axis. Is anybody still writing this down? Okay. Here. Pretend you're looking at a side view of that bell. That's not bad, right? Do you agree when that bell gets unfolded, what are the cross sections if I slice them perpendicular to the x-axis? If I were to take that bell, slice it, and look at the side of it, what shape would that be? Let's make this easier. See this thing? That's not a cylinder, is it? Agree? Now, what happens if I were to only look at the top half of this, okay? And then spin that around and get this shape. If I slice it this way and I look at it, what shape is a cross section as you look at it? Circle. Slice, circle, slice, circle. Slice over here, smaller circle. Ready? Slice this bell here. Well, wouldn't this have swung down when it opens up? And wouldn't you get a circle there? Right? And over here, it's not as big, but it still swings down and creates a cross section of a circle. Do you see what I'm saying? Okay, that's a cross section. Now, if I wanted to find one of those cross sections, what if I want to find the area of that one circle? What would I need to know? The only thing you need to find the area of a circle is the radius. What's the radius of that circle? It's the height of the function. If this black thing right here is my function, isn't the radius the height of the function? Because it's attached to the x-axis. Isn't this bell completely attached to the x-axis? You see what I'm saying there? Because isn't the x-axis kind of like the thing it spins around, right? I mean, it's opening on that axis. Does that make any sense? So the area of this circle is different than the area of this circle. If you zoned out, you need to listen right now. How do I find the volume once that thing is opened up all the way? I need to stack all of the circles side by side and add them up. You follow me? What does stacking in calculus, in integral? It stacks either rectangles from left to right, or in this case, if we can find an area function, if we can find an a of x function, we can stack those a of x's and get volume. Are you with me? It just so happens that this a of x is a circle. What if you take this thing and revolve it around the x-axis? What shape are you going to get? Not one cross section. What's the whole shape going to give you? A cone. Very good. Do you see it? This gets spun around and comes down here. This gets spun around and comes down here. What's the radius of that a of x function? Well, they're circles, aren't they? What's the radius of that circle? The height of the function. The height of the function. Are you with me? All you need to get volume is to find out what your area function is. And if we're spinning these around an axis, I mean, pretend everybody's done this, right? You have something in your hand, like those little paddle things with the rubber band and the ball in the end. If you spin one of those around, right, anytime you spin, it's going to give a circle. You spin something around, it's going to give a circle. If you revolve something, axis of revolution, you're going to get a circle. The only thing you need is the radius, pi r squared. And if you stack up your pi r squareds from left to right, you're going to get volume. So here's another visual. Let's say we take this region. This is a parabola, it looks like, and we have an A and a B, and we revolve this around the x-axis. That's the volume it generates. I'm not good enough to draw that, so I just found the picture. Can you visualize that? Some people really struggle with visualizing these. Can you visualize when this gets spun around the x-axis, you get that? It's like one of those coin vortexes, the Hartwell kitchen. You know what I'm talking about? Put the coin in, it goes in. But this is a very boring coin vortex because it's solid. Right? There's no actual vortex part. All right. Now, what if you have R of y's? Make me proud. How are you going to know whether you're doing R of x's or R of y's? Good. Good. It's going to be R of y if you're going around some horizontal line. Yes? Closer. Nice.
It's all 4 boxes.
Do you agree? If we had some function that went like this, I could revolve it around the x-axis and get that bell. Or I could revolve it around the y-axis and get something a little bit different, maybe a Hershey Kiss. See it? So it depends. Now, if you're doing R of y, eyes up here. If you're revolving it around the y-axis, wouldn't your radii, if I take my hand and I don't spin it this way anymore, I spin it this way, aren't my radii now going this way? It's not a y value, it's an x value, and the x is some function or relation of y. It's a radius of y. That's why I had you draw in those rectangles in 7.2. If you can draw on one rectangle, it's going to tell you, am I using dx? Ready? Doesn't that have a dx width base? Doesn't this have a dy stacking? Right? We're stacking this way. Does that make any sense? I'm trying to help you. Right. Not so bad. Disk method. Here we go. Find the volume of the solid formed by revolving the region bounded by the graph of y equals radical x and the x-axis. So y equals radical x. And the x-axis from 0 to 4. So every question is going to have several parts. There's going to be a region being described. There's going to be an interval, and there's going to be an axis you're revolving it around. So here's our region. All right, we'll call it Bullet Bill. Anyone?
Mario.
I hate. Okay, Mario Kart. Like, I don't know, but it bothers me how socialistic it is. Like if you're in last place, what are you gonna get? You're gonna get Bullet Bill. You're gonna get Star. What do you get in first place? Banana peel, coin. Old Mario Kart. Always get a banana peel.
Feel the same way about looking.
And you get the blue rocket hitting you.
It's a shell.
Blue shell.
Yeah, the blue shell.
Really?
Or people behind you red shells. All right.
Look, it's the same thing.
What's up?
Look, it's the same thing. You can jump from last place to first place in like 3 questions.
And how does it make you feel?
It's upsetting because I'm in first place. I worked so hard to get first place. And
Thank you.
Comes up and just
Thank you. All right, I'm not trying to get political here, but whatever. All right. Do you agree? That is the region. That is the two-dimensional region that is being described before it's been revolved. Yes? Once this gets revolved, here's all I'm asking you to do. Draw one rectangle in the region. How do I know to draw it up and down? These are questions that are going to come up. How do I know to draw it up and down?
Because you have no right not to do it.
Okay, what else? We're going around the x-axis. My hand is going right this way. These things are getting spun. That thing I just drew is now 7-2. Ready? Section 7-2. That was a rectangle that we're using to stack up. Today, it's the height, which turns into a radius that generates a circle. Do you get it? So this is it was a dx thickness. It's an r of x. It's an r of x radius, and r of x happens to be radical x. So if you need some stepping stones here, r of x is radical x. A of x, what is the cross-sectional area that gets developed when we spin that around the x-axis? Pi r squared. Do you agree? Pi r of x squared. Quick little pause. When will r of x not be f of x? Here, r of x was f of x. Any predictions? Dom. Good job. What if the region isn't connected to the x-axis? What if it's connected to the line y equals 1? And this is not shaded down here. Wouldn't the radius be, top minus bottom, right? If we're going around this line. Or what if we're still going around the x-axis? We'll get into that Monday. All right? We'll get into that Monday. But real quick, what if we're going around y equals 1? What would that radius be? Because now it's spinning around this thing. It's still solid, huh? Good. It's square root of x minus 1, top minus bottom, isn't it? If you're going around that line. Real quick, it would look like this. Okay? But it would have to tell you the region is the region bounded by radical x on the top, y equals 1 on the bottom, from, I have to tell you some bounds. All right? Am I making sense? And I'm not trying to complicate things. I'm just trying to get you to not always say r of x is f of x. But today, it is. So, how do we get volume? Volume is the integral from 0 to 4 of that a of x formula, pi radical x squared dx. And I know radical x squared is just x. I'm just writing it there so you see it's a circle formula, pi r squared. All right. If you want to plug in pi x dx in your calculator to get that volume, you're welcome to. Has anybody plugged that in yet? All right, let's get in the habit. Let's go ahead and plug it in. Is it 8 pi? No? Did you do it in your head? Huh? Yeah. It's not hard. Look, isn't this just pi x? What's the antiderivative of pi x? Pi x squared over 2 plus c. Pi x squared over 2. Plug in 4. Pi times 4 squared over 2. 8 pi. Minus 0. Did you get 8 pi? Exactly 8 pi. And no, there are no units on these. They're not going to ask you to give cubic units of measure. That's kind of cool, right? I mean, that's not any shape we know. But we can still find the volume of it, right? Kind of cool. Questions on that process? Next, find the volume of the solid formed by revolving the region bounded by the graph of 2 plus x cosine x and the x-axis on the interval from -2 to 2 about the x-axis. All right, part of this is understanding what you're looking at. So if you haven't taken out your calculator, go ahead and take it out. We're going to graph 2 plus x times cosine x. Don't forget to put a multiplication symbol in there between the x and the cosine x. It might panic if you don't. Did you get that graph from -2 to 2? Now, read carefully. Find the volume of the solid formed by revolving the region bounded by the graph of 2 plus x cosine x and the x-axis. Here's what I recommend to students. As soon as you read it, shade in the region, and then I call it a rotational arrow. As soon as you see it going around the x-axis, put a rotational arrow around the x-axis to remind yourself what it's connected to and what it's being revolved around. Next step, draw in one sample radius. Are these going to be dx's or dy's? dx's or dy's? dx's, good. And that r of x is, again, it's the function height in this case. It's the function height. So r of x is 2 plus x cosine x. Who can raise their hand and tell me a of x? Tom.
Pi times 2 plus x cosine x squared.
Thank you. And volume is the integral from, yeah, we're stacking all these circles, and they're calling them discs, like, you know, like a frisbee, like a disc like that. All right. They're calling these discs, and they're being stacked from -2 to 2. So -2 to 2. Pi 2 plus x cosine x squared dx. Now, here's how I do it. If you want to pause and watch up here for real quick. Do you see how mine's called F3? Everybody see it? F3. I go out to the calculator window and I go integral -2 to 2. Here's the pi button. It's right down here. Pi come on. Times escape. Times don't do that. You're a jerk. No. Oh, don't do that. All right, you gotta be smarter than the calculator. Pi times. All right. My r is the function, right? And it was called F3 in my calculator. So I'm gonna go to variables. I'm gonna go F3 of x because I'm too lazy to type it in again. Now here's the tricky part. I'm warning you. It's tricky. You got to find out where to put the square. Okay. There's so many parentheses in these calculators. Do you agree? This is the f of x. It's here. This parenthesis closes the x. This parenthesis closes the f3 of x. Don't I want to square f3 of x? Do you agree? Yes? Dx. I'm getting 52.429. Do you get 52? Always the three decimals. 52.439. 429, sorry. Okay, hang on tight for 1 minute. Questions on that one? Why didn't you get something different? You good? All right, here is a, I want you guys to see one in context of an AP free response question. Okay, ready? Part A. Section 7.2 or section 7.3? Area of R. 7.2. Part B, find the volume of the solid generated in R is revolved around the horizontal line y equals 6. We have not done this yet. I bet you can figure it out. Ready? Part B, you're revolving this around that axis. I want you to do part A. Before you write out part B, I want you to talk about it together. Okay? See if you can figure out what the R of x is going to be and then what the A of x is going to be. So what probability? Oh, probably isn't that active probability. Complement. What is the complement of that? Okay, I roll 3. What's the complement of that? What's complement of that? Need it fast?
No.
No?
Because yours is about 6.
No. No, it's not. Did you get that for part A? Integral 0 to 2, 6 minus parentheses 4 ln 3 minus x dx. Yes? That was a 7-2 question. Top minus bottom. I honestly don't care what the number is. I want to do this. The setup is most important. Like, you guys can type it in. Have we tried part B yet? Who wants to volunteer? For those who are struggling, who wants to volunteer an R of x radius? Chad.
I think the radius is the top minus bottom. I think it's 6 minus 4 ln 3 minus x.
Agree? Disagree? Okay, what if you're going back to a geometry student and you're trying to explain this to them, and you say, okay, take this red line. Do we all agree that's the red line we're trying to find? Like, that's the length. And you say revolve it around like 6. What is the radius? Isn't the radius defined as the distance from the center to the outer edge of the circle? Isn't it top minus bottom? Right? That's right. Yeah. It's 6 minus 4 ln 3 minus x. Okay, well, if you can do that, you're good. Part B, the volume, where are we starting to stack those circles? 0, 2, 2. It's just a pi r squared, isn't it? Are these, second question, and this isn't really a question yet because we know there's only one option. It's the disk method. Is that shaded region completely connected to the axis you're going around? Are there any gaps we have to worry about? No, it's solid, isn't it? Right? What if we went around the x-axis? Wouldn't that shaded region have gaps when we revolve it? Can you see it? That's a different method. Today, it's not. Pi r of x squared dx. This is your area function, pi r squared. It's called a cross-sectional area formula. How do we feel about that? Again, you can type it in. I don't want to spend time right now typing that in. That is directly from a free response question. Here's what I'll say. Of the 21 years of what they call modern tests that have been given, everything after 2001 they're calling a more modern test. This happens as a free response question about 70 to 80% of the time from my experience. All right. Of the 6 FRQs, this is one of them. Area, volume, and then some random, I deleted out part C. Some random question about the solid. Okay. How are we feeling about the disk method? All right. Seven 3, day 1 in the books. 7 through 12.
Bailey left her balloon racers below the desk. She also spelled wheels wrong. That's like a student or...
It is. Seven through 12. 7 through 12.